It's the third one, session 8.
First of all, thank you for all of the audience for the assistance today to the International Conference on Optimization Application. So we move on now directly to speaker one, in this phase. I will present analysis of the impact of data design on the training of agricultural product classifiers.
And of course, I would like to thank you all for your presence here in this conference. My name is Professor Mubarak. We will lead this session with Professor Idris Mahdash. So you have 10 minutes to present the session.
I will try to do it as fast as possible. My pleasure is mine. My name is Idris Mahdash. I'm a researcher from University System Engineer Lower of your twin school in south of Taiwan. My work is analysis of the impact of dataset design on training of agricultural products classifiers. To do so, please, I will pursue this plan, starting by introducing the main goal of my analysis, then directly to the point, my contributions that have for steps, datasets, feature profiling, building and balance strategy.
The most important thing is the environmental factor. For example, there is some datasets as Fruits 316 that are often too controlled, which means they are taken in very good conditions, such as this uniform background, white background, which is limiting in the real world generalization. So my contribution is to form a new dataset that's balanced in terms of variability of certain visual features, more than 18,000 images with 24 different categories. Also, a feature profiling across 5-dimensional visual features such as texture, color, lighting, background, culture, and deformation. I will present also a reproducible pipeline that you can use also for your training methods. With quantification, building, and balancing sampling. And finally, I will finish by experimental validation of my method. So the dataset is contain 34 classes from different fruits and vegetables, starting from banana to carrots. I took a number of resources, open source. You can find this in the internet. I gave it to you already in the references. You can find them. So there's Fruit 316, the Kaggle datasets, 2 Euro collections. They are analyzed in Coca format, more than 2,500 images per class. So before attempting the balancing, you have to understand that the recognition difficulty depends on some visual features. The classification errors don't depend only with the model architecture, but also in terms of dataset bias. For example, datasets, if you took in only images that are well lit with the same texture, for example, soft texture with an example of class kiwis, you will find difficulty to recognize in the same class but in different conditions such as rough texture or low lighting. So what we do here, we try to do a study of a feature profiling, starting by finding the quantitative predictors for every score. We found that the visual feature that have the most impact on the classification error are texture, color, lighting, background, deformation. For the pipeline, so what should I propose? My plan can deal with first of all, I'm input for data sets that have heterogeneous in terms of agricultural products. My outputs having a balanced dataset that will pass from several steps. The first step is the feature extraction. Second one is the pinning, then the balancing, and finishing with validation. So what we do in the feature extraction, we transfer, it's very simple. We transform each image per class into a five-dimensional vector. Five-dimensional vector, which means that we computed a texture score, lighting score, and all the rest of level scores. Those curves will pass through another step, which is binning. What we do in binning, we contextualize those vectors into a meta table that represents the whole data set. Those bins, for example, I will give one example. We have kiwis that have low lightning with a clutter background and so on. So what we do with those bins, we use it to balance our data set. So what is the strategy, balance strategy I use? So it's very simple. First of all, we have to detect which are the underrepresented bins. For example, what I found in my data sets, I found that certain bananas the underrepresented bins are high texture or flatter texture background with some other objects, which means a high occlusion. So what I did an augmentation of the dataset of those rare bins using a duplication with methods such as rotation or changing low lightning. Sometimes in severe times, I use a GANs or a function that generates news pictures. Also, I have to train the model. It's very difficult. It takes too much in terms of time and resources and memory. So I didn't focus more on this. And finally, we validate our data sets with computing the Shannon entropy and linear impurity. So what I did before attempting this balancing, I started by a feature profile of the previous data sets. I found that my first data sets is very large, but the problem is to control the same uniform background for all classes, which means that it's a poor generalization. For the Kaggle, moderate diversity, but a limited number of class. The ULOs are realistic seen, but imbalanced in terms of classes. So the model architecture, I didn't focus on this part because the most important thing was the impact of the data sets on the accuracy. So I used a classical CNN, exactly with a core mobile nights. 18% for training, 10% for validation, 18% for states. I have just to mention here that testing was done with the newest dataset, not with all the previous one. So I can do the benchmark. So with the benchmark, the same model with the same dataset for testing, I found that the YOLO version 8 have the best accuracy, but we have to concentrate here more on the miscalculation in certain scores. Exactly or occlusion score is very high. I found this very high. So I did the same thing, but with the newest dataset, I found this an improvement in terms of accuracy, more than 5%, and a strong reduction in terms of reduction in occlusion-related errors. So for key insights, I hope I took not more time. I will conclude here. For the key insights, the most important key is the final one. So for my pipeline, there is a way, an iterative way, which means that if you train your models and you find a percentage of errors, you can do a study on those errors and find which miscalculation you found per class, so you can know which class you have to augment in terms of datasets for your to have a better accuracy. For my conclusion, I demonstrate some robustness gains for CNN architecture trained in a formal or formal. My future direction, I think I will concentrate more on using these for data balancing, and why not doing a benchmark assembly with using more complex architectural networks such as networks and other methods. Thank you for your attention.
Thank you, for this very important presentation. And thank you for the clarity of the presentation. and we move on if there is any question.
Very helpful. Okay, thank you very much, Mr. Faiz. It was a very interesting presentation. So I have just one or two questions. My first one is how did the dataset affect the generalization capability of your agricultural classifiers?
Impacts the generalization training or classification errors. Which parts?
Agricultural classifiers.
Classification.
Yes.
So it was the main of my problem here. First of all, my first work I did only with one dataset, which is trained 16 dataset. It contains all the per classes, but they have a uniform condition. They are kept in very good conditions. So my study is to have first of all a balanced dataset with in terms of variability. So which means, for example, I will give you an example. If I took only oranges, I tried to do a balance which in terms of lighting. So I did. So my base was low lighting, medium lighting, high lighting. Then the same number of low lighting there is up in the same number. The third number of low lighting is the same for medium one and for high one. The same thing for every spot. So what I did to find this formula is to find the rarest beats, the rare combination, and trying to augmentate with, first of all, duplicating the same image but rotating it, or trying to play on the lightning, or adding other objects in the background, so I have this confusion, and calculate the score and try to have the same score for every category. So this is my way. The impact, it was because what I did for my, in terms of testing, I tried to test with the newest datasets, but the training was with previous datasets. So I can say how the model is reacting in this, with this formula. I think I...
Okay, thank you very much for your answer. So my second question is based on your findings, what improvement would you suggest for future dataset collection in agricultural image classification?
Yes, the use of GANs, more GANs, because GANs, the first operation was only the duplication of the same image plus changing its rotation. If rotation isn't, we rotate it 18% or 90%. So those treatments are not, we didn't augmentate it actually, but we using GANs, we creating another picture with the same beans that we need. We define the beans, the rarest beans, and the representative beans for the dataset, and try to applicate the gains to create them. So I think this technique will improve my accuracy. I hope I do this for the next conference like that here.
Thank you very much.
Thank you. Yes. No more questions?
Yeah.